Hello everyone, we're Excellent Fuseki Interface and we're here to present an innovative solution to bridge the gap between a Tableau data store like Excel with a knowledge-based data store like Fuseki. So as you may already know, Microsoft Excel is a software widely used for representing data in a tabular structured format. Despite its popularity, Excel is limited in terms of being able to query data in a complex manner and manage interacting groups of data. For engineers and professionals who mainly use Microsoft Excel as a hub for data control, they are not able to use advanced queries and relational operations due to the intrinsic limitations of Excel documents. This results in inconvenience and time lost in terms of managing and analyzing data. This project aims to address this common problem regarding Microsoft Excel usage in terms of customizability for managing data. This benefits the user in many ways. Our solution, EFI, seamlessly integrates Excel data with the advanced querying capabilities of the Fuseki graph database. This integration not only enhances Excel's functionality, but also leverages the power of a sophisticated knowledge base. As a result, EFI enhances both data analysis and collaborative efforts among engineers by maintaining crucial data relationships through effective mappings and data flow mechanisms. This opens the door to large-scale data analysis and data pipelines for more complex use cases.
This is a demo of our application. First, the user sees this welcome page where they can click Get Started to sign in, or they can register for an account here. So we'll first demo what an admin user can access. So if we log in as an admin, we get to this page where the admin can view the mappings, and they can also create one here. You can give it a name, graph name, some description, and they can give it a relation, which is something like this that specifies the relationship between two attributes. They can also specify some Excel format. And we press submit and we get this confirmation. And if we go back, we can see the mapping we just added is here. And as an admin, you can also modify these mappings, which takes us back to this page where you can edit it. And admins can also delete mappings. So if we go back to the home page, there are these three features that are also general user features. So we can demo that on a user account that doesn't have admin access. We go back here, log in as some user account. And we can see here that they only have these three features, the first being upload mappings. And the mapping that we just added as an admin is here. And the user can also search for a mapping just to easily find one. So if a user wants to upload new data to a mapping, for example, we have this sheet with attributes and a relationship. A user can upload this Excel sheet. They can pick a mapping and press upload. And then we get a confirmation that it was processed successfully. The next feature is downloading mappings to an Excel file. Let's say we want to download this mapping. We can submit it and then we get this confirmation of the mapping we picked and a preview of its data. And then we can press download and we can see it's successfully downloaded. And if we open it, we can see that the data is there. Then going back to the home page, the last feature is visualizing mappings. A user can pick a mapping to visualize. Let's say they want to visualize this mapping. You can select it, and it gives a graph representation of the relationships between the attributes that are specified in the mappings, which you can just reference or you can save.
Now let's talk about the architecture and design choices. For the architecture description, we chose the monolith for the entire application for the easiness of deployment and the speed. For the internal layout, we chose Django, Apache and Fuseki, as well as the PostgreSQL. And for the UI design, we chose MVC. So as we can see the diagram shown here, it illustrates the EFI's workflow within the Docker-contained environment. So the user requests from devices are processed by the Django Web Framework, which retrieves and sends data mappings from the PostgreSQL database to the Fuseki server. And Fuseki manages and returns the graph-based knowledge data, which Django then delivers as response back to the user's device. And for requirements, we make sure that data transformation between the Excel and the graphic formats are achieved. And it also ensures the user interaction operations such as the import and export. It also achieves the scalability, security, and performance of our application. And for design patterns, we use the MVC design pattern to separate logic into distinct layers to make it highly modularized. So the MVC pattern in our Django-based application, as shown here, modularizes the user interface and backend logic, enhancing the maintainability. And the Django templates act as a view, interacting with the controller in view.py to process requests and update the interface, catering to the user-friendly experience for both administrators as well as end users. Okay. For the second design pattern, we use single pattern to ensure consistency, so that a single authenticated state per user to maintain the session integrity. So in this way, we make sure that user data added is safely stored without any corruption. And for the non-function requirements, we make sure that there's only a single access point for the resource-intensive application operations to make sure that we're not wasting any resources.
This is the implementation, testing, and CI/CD section of our project. In terms of the implementation, the programming languages we used were Python, HTML, and CSS. Python was used mainly for the backend, being able to interact with our backend database systems and other things, whilst HTML and CSS were mainly used to be able to actually make the front end be working and look nice. In terms of off-the-shelf components, we used Fuseki, Postgres, Docker, and GitHub Actions. Fuseki was used as a graph database to be able to store the data in Excel files in a parsable form. Postgres was used to be able to store the mappings and other meta information for our graphs, which helped us be able to do other functionalities within our project later on. Docker was used to containerize all of the components of our project, making it easy for us to set them up on separate environments without having to actually worry too much about the infrastructure. And then GitHub Actions was used for our CI/CD pipeline, which we'll talk about later. In terms of frameworks, we used Django for being able to connect our stack together, and its usage of MVC paradigms made it really easy to make the full stack application work. Testing strategies. One of the strategies we used was unit testing. We used Django's built-in unit testing framework to be able to actually make this happen, which made it really easy for us to test the backend and the front-end interactions as they were being made throughout our project timeline. Regression testing. We also did regression testing, which was done using GitHub CI/CD using Actions, where the CI portion was mainly done by being able to rerun the build and deployment scripts and rerun the test scripts on a brand new machine every time that we made changes. So we checked to see that our changes didn't regress in the end when we were making new additions to our project. And a little bit more about the CI/CD. GitHub Actions allowed us to make it so that on pull request, we could actually check that our changes were being made functional on a new device completely, and be able to actually make sure that everything worked and then set it up and start it. But we don't actually currently have anywhere to deploy to. So given a domain, we could actually do the continuous deployment part by just changing our previous scripts for the pull requests to be able to actually implement this instead. And yeah.
The Scrum process consists of bi-weekly sprints and stand-up on Fridays. We totaled 3 sprints each 2 weeks apart. We also had work session meetings on Thursdays for last-minute debugging. Sprint statistics-wise, we attributed 1 task to 1 story point and achieved an average speed of 7.667. You can see in the chart below that Sprint 2 achieved the highest amount of points. Contributions were divided between backend, infrastructure, and full-stack or front-end roles. The tasks are outlined below. As a team, we learned several lessons. So for instance, that agile processes encourage collaboration, that flexibility is inherent in Scrum. For instance, you may add or remove tasks in a sprint. We also learned that lots of research is required to integrate with external APIs. Namely, we had challenges trying to integrate the Fuseki interface with testing frameworks. For future work and potential improvements, we can host the application to the public and also allow the visualization of mappings to be able to be dynamically changed. And these changes will also dynamically reflect in the database. We can also integrate with PyPlot by generating Excel files that not only contain data, but also embedded graphs that were generated from the data.